Hey guys, welcome back. In the previous video, I was talking about the beamforming using vectors. So let me continue that because I wanted to take one particular example related to this. So what I was mentioning is that in case of MIMO 2 cross 2, okay, so when we have this transmitter and the receiver in between that, we got a channel edge, okay. So this channel H, when we transmit two symbols x1 and x2, we can represent the system model something like this. So from here, I was mentioning that the columns of this matrix H represents the fundamental directions along which the signal is transmitted over the air or in the 2D space. So this was first column, this was second column along which x1 is transmitted, x2 is transmitted in the space. It is equivalent to saying that the signal is transmitted in these directions. Okay, so I was taking an specific example where the channel matrix H is equal to 1 1 and 1 minus 1, 2 cross 2 matrix. So along 1 1 the x1 is transmitted, and along 1 minus 1 x2 is transmitted. So for that I had written a diagram over here, but I wanted to mention a small correction here. So for 1 and minus 1, it is x-axis 1, y-axis minus 1. So the direction is like this. Okay, so this is 90 degree, so not this one. Okay, this is the one. So if you want to take this as the direction, then you have to take a minus 1 comma 1. Okay, but what I'm taking is 1 and minus 1. So this is the direction, but still the same concept what I had explained in the earlier video, that holds good, because this x1 and this x2 directions are orthogonal to each other. This is 90 degree. So considering this, at the receiver side, I was mentioning that we can perform some kind of receive beamforming weight with this operation, and then with that we can try to get x1 and x2 separately to get x1. So I was mentioning that as per this diagram, since x1 and x2 are orthogonal to each other, if we see in the same direction as x1, then we will get x1 completely, and there will be no component of x2, because x2 is orthogonal to x1, right? So I mentioned that one, and even some mathematical expressions also done over here. So and also I was mentioning that since we are going to perform some kind of weight to the received signal y, we at the receiver we are calling it as receive beamforming concept, right? So with this, I wanted to jump to another example. I want to take another example where h is equal to 3 1 2 1. Okay, in this case, the fundamental directions in 2D space would look like this: 3 1 is here, 2 1 is here. So as per my previous explanation, x1 is transmitted along column 1, and x2 is transmitted along column 2, right? Okay, at the receiver side, what do we need to do? Usually if we do zero forcing receiver, then this is what we will get, right? So here in this case h inverse exists. I have taken h matrix such a way that h inverse exists, but the thing is that here the columns of h are not orthogonal to each other, and even we can see that in the 2D space, right? So between h1 and h2 the angle is very small. So definitely, if we try to look into the same direction as that of x1 to get back x1, it is not possible, because since x2 signal is also very close, so you will get some component of x2 as well. So then what do we need to do? So this is the h inverse, right? From here we can derive the weight matrix or weight vector which we need to do, which we need to perform on the received signal y bar. So usually w bar admission, y bar is the consideration, right? So what would be w bar? Let's say W. So W would be here in the H inverse. We should consider the row vector. Okay. So then my W would become 1 minus 2. This is the vector I should be using as a receive weight vector. If I use this, then if I perform this operation, then what do I get is I would get x1. Okay. So now let me draw this W bar in the 2D space, and let me see how does it look like. So W bar will be 1 and minus 2. Okay, x-axis is 1 and whereas y-axis is minus 2, so it would look something like this. And if you clearly see, this would be orthogonal to x2, because right now we are looking for x1, right, x1 signal. So over the air it is transmitted everywhere, but the fundamental direction is along 3 comma 1. So you at the receiver side, based on this example, it says that you should look in this direction, so that in this direction you will not have any component of x2, because this is orthogonal to x2, and you will have some component of x1, so that you have required x1. Similarly, if you want to get for x2, what do we have to do? So you have to use a vector minus 1 3. Okay, this is the second row here, that will become the weight vector minus 1 3. So this is minus 1 and 3, right? So this will become, so this will become something like this. So this will be orthogonal to x1, whereas some component of x2 will be there in this direction, if you look at the receiver side. I hope you got the clarity on how these channel matrix H and the different weight vectors are performed based on the concept of this beamforming at the receiver side. So with this example, I will wind up here. In the upcoming video, let us talk more about this channel matrix H and beamforming using SVD and things like that. There you will get much more clarity related to precoding and the transmit beamforming and receive beamforming, because in this video, for this example, we are not applying any kind of weight at the transmitter side, and there is no transmit beamforming, whereas the beamforming is happening because of the channel conditions, right? So I was mentioning that these kind of beamforming in a particular directions are happening because of the channel conditions. And um, and uh, and at the receiver side, to get back x1 and x2, we are performing some kind of for receive beamforming by using a weight vector wr, right? So by that way, we are performing only receive beamforming here, and there is no transmit beamforming. But in the next video, in case of SVD, we'll try to see the both the transmit and receive beamforming happening, and how to perform that, and what are the kind of vectors that we should be using there. Thank you very much. Have a great day. Bye bye. Please stay tuned.